Hey everyone, welcome to 8.2 about substituent groups. So we're still working with organic chemistry, but now we're going to start talking about the groups coming off of the parent chain. So real quickly, if we were to draw an organic compound like you see up here, it's easily translated into something that looks just like lines. So everywhere you see an end of a line or a curve in a line, that's representing a carbon. You can figure out how many hydrogens are branching off of it just based upon the fact that carbon always wants to make 4 bonds. So this is the end of a chain. So there's only a carbon here. It's connected, so it must have 3 hydrogens on it, which is like CH3 here. Since this is a carbon and it has 2 connections, that lets you know it can only make 2 more connections or 2 other hydrogens. Right here is a carbon, it's an intersection, but it has 3 connections already, so it can only possibly make 1 more hydrogen connection. So the end of a line, an intersection, or a curve represents a carbon. So for example, if I were to draw just this right there, how many carbons is there? Well, there's 1, 2, 3. This is a CH3. This is a CH3, and this would be a CH, how many hydrogens? Well, it already has 2 connections, so it's a CH2. What if I drew this here? Well, you have 1, 2, 3, 4 carbons. You can figure out the name for that. If it's a 4-carbon chain, what is the name? 4-carbon chain, what is the name? The name is butane. So on each end is a CH3, and these middle ones are CH2s. So if you wanted to write the structural formula for butane, you'd have CH3, CH2, CH2, CH3, because structurally it literally goes CH3, CH2, CH2, CH3. But what if you wanted the condensed formula? It seemed like some of you had confusion between structural and condensed. Condensed means let's just put it all together. All you have are carbon and hydrogen. There's 1, 2, 3, 4 carbons. And so then there's 3, 5, 7, 10 hydrogen. That is the condensed formula. You could also figure that out based upon that generic formula, the CnH2n plus 2. That is your alkane general formula. So if we were to look at this alkane, the parent chain happens to be horizontal right here. This is the parent chain. If I drew the circle around the parent chain and named the alkane, will be based on the name of the parent chain. So this was in the last video as well, and again, that should be alkane. It's called hexane because hex means 6. You see 1, 2, 3, 4, 5, 6. Everything else, though, is what we haven't yet talked about. Anything that's branching off of the parent chain. You can see that, and I'll circle here and here. Those are called substituents. Anything that's branching off the parent chain. So the total number of substituent groups is how many? Well, there are 2, right here and right here. To name substituent groups, first count the number of carbon atoms in each. Communicate the number of carbons by choosing the correct prefix and just adding YL. So if we're to look back here, this is 1 carbon, and this is 2 carbons. If you refer to your prefixes for 1 through 10, 1 carbon, the prefix is meth. But instead of saying methane, because it's a group now, we'll call it methyl. So what would be the name of this substituent group with 2 carbons? Well, the prefix is eth, and since it's a group, it would be called ethyl. So you have methyl and you have ethyl. So the substituent on the second carbon atom right here it has one carbon, so it's called methyl. And the substituent on the third carbon has two carbons, and so it is called ethyl. Here is a list. You should be familiar already with this here. So if there were 4 carbons, we would call that parent chain butane. But now, if they're substituent groups, all you do is keep the same prefix like meth, eth, prop, but add y, l. And we'll go through a few examples with that. Next, you want to communicate the location of the substituents on the parent chain. This is done by numbering the carbons on the parent chain. You can start at either end of the chain, but you want to have the smallest possible numbers. If there's a tie, the substituent that comes first alphabetically gets the smallest number. So in the box on the left here, if the carbons are numbered from left to right, you'd have a group here on carbon 2, and then you'd also have a group on 3. Over on the right, if we numbered from right to left, we'd have a group on 4 and 5. So if numbering begins on the left, we'd have substituents on 2 and 3, which is a total of 5. If we went with this one, we'd have substituents on 4 and 5, and that adds up to 9. Your substituents must have the smallest possible numbers. So, which is the correct numbering? 2 and 3 would be the correct numbering. So if we were to look at these, our parent chain, either way, has 6 carbons. So that's going to be hexane. So if we were to look at these, this one here, from left to right, you have 1, 2, 3, 4. If we went from right to left, it'd be 1, 2, 3. So 2 is lower than 3. That from left to right is the correct numbering. Since there are 4 carbons, that's going to be called butane. Then we need to start introducing the different groups. So since this is only 1 carbon, what would be the name of that group? It's called methyl. We also need to indicate where it is on the parent chain. It's on the second carbon. So it'd be called 2-methyl-butane. In B, it's already numbered for us that the largest chain is 7, numbered from left to right. We have a group here on the 3rd carbon and on the 4th carbon. If we had numbered the other way, it would have been 1, 2, 3, 4, 5, 6, 7. Since 5 is higher than 3, numbering from left to right is the best option. So in this case, we have a 7-carbon parent chain, which would be called heptane. Then we have 2 different groups. We have this group here, 1 carbon, so the name of that is methyl. And then we have a 3-carbon substituent group, not parent chain. So what would be the name of this substituent group? 3 carbons. It's called propyl. We list our substituent groups in the name in alphabetical order. So we have methyl, M comes before P, and we also need to say the location. So we would have 3-methyl, and then we would have 4-propyl. Sorry, that should not be there. So 3-methyl, 4-propyl, and we use these hyphens to separate the different groups. So anytime you have a number next to a letter, you want to put a hyphen between it. Now C, you need to figure out the longest parent chain and the best way to number that. So let's look at a few different options. We could do 1, 2, 3, 4, 5, 6, 7, or we could have 4, 5, 6, 7. This would only be 5. So your best option is definitely the 7. And then you want to see which way to number it to have the lowest groups. So if we number it from left to right, this would be 3 and 4 is 7. If we use this way, it'd also be 3 and 4. If we went this way, we'd have 4 and 5. So left to right is the best option. 1, 2, 3, 4, 5, 6, 7. Now take a moment and try to name that on your own. The entire name with these different substituent groups. Okay, so it is called hexane, since there are 7 carbons. We have a substituent group on the 3rd carbon and the 4th carbon. 3 carbons is going to be called propyl again. And 2 carbons is going to be called ethyl. Putting them in alphabetical order, ethyl would become first before propyl, and it's on the 3rd carbon. So 3 ethyl, 4 propyl, hexane. That's the full name. Try again with these on your own for a moment. Pause the video. Okay, welcome back. Hopefully you were able to name these on your own. The first thing you always want to do is identify your parent chain and decide in which direction the numbering would be the smallest. For the first one, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 carbons. You can use this as a parent chain, or you could even turn it, but either way, it's going to be the same. So I'm just going to go ahead and box my parent chain. And also number it. The numbering is going to be smallest from right to left. So 1, 2, 3, 4, 5. I'm just going to stop there because we don't have substituent groups after that. Then I'll go ahead and circle my substituent groups. We have this 1 carbon, so that would be called methyl. And then we have a 1, 2, 3, 4 carbon parent chain, so that would be called butyl. So if we were to put this together, there are 10 carbons, so the parent chain is called decane. Always with this ane ending because there are only single bonds. Then you want to put your substituent groups in alphabetical order. So we'd have 5 butyl, 3 methyl, decane. This one here, we'd have 1, 2, 3, 4, 5, and it's actually going to turn 6, 7, 8, 9. 1, 2, 3. So whether we did this one or this one, either way is fine. Numbering would be lowest if I went 1, 2, 3, 4, 5, 6, 7, 8, 9. So it is nonane. There's a substituent group here and here. So the 2 would be called ethyl. The 1 would be methyl. So ethyl comes first. We have 3 ethyl, 5 methyl nonane. Here you're going to have 1, 2, 3, 4, 5, 6, 7, or 3, 4, 5, 6, 7. So we'll just go with this parent chain that's straight. Lowest numbering, we could have 2, 5, 6, or 3, 4, 6. So either way, it's the same. So instead, we have a methyl, ethyl, propyl. So in which direction would the ethyl the lowest alphabet